Okay, guys, good afternoon. So today is our last lab number 5, which is we check the compressive strength of concrete cylinder. Okay, so we should have lab number 6, which is high strength concrete computation. But for this semester, I just decide we do not do the lab for lab number 6. So we only do the high strength design. Okay. So again, lab number 5 today is our last lab for this semester. Okay. The lab report, which will combining lab number 4, which is fresh property of concrete, and number 5, which is compressive strength of concrete, is due on November 30th for our group A and B. Okay, so again, this is one group report. Every group will just submit one report to me. Okay, so due on December 30th. So the objectives of this lab is to determine the compressive strength of concrete cylinder at 1 week, 2 weeks, 3 weeks, and 4 weeks. Okay. The procedure is pretty simple. First of all, we get a cylinder which is cured in the curing bath. Okay. And we should cap the top and bottom end of the cylinder with sulfur compound. Okay. The goal for this using sulfur compound is to make sure the top and bottom end of the cylinder is smooth. Okay. Otherwise, we're going to generate stress concentration if the surface is not smooth. So that will affect the results. Okay. So this is going to be done by our TA. And then we put the cylinder in the compressive strength machine, and we check how much load the cylinder can take before failure. Okay. This is for the procedure in our experiment number 16 in our textbook. Okay. I will upload all the raw data. So 7, 14, 21, and 28 is raw data, which is how much load in pound the 3 cylinders can take at different ages. And you should calculate the 7, 14, 21, and 28 days strengths. Okay. Okay, for example, this is 7 days strength, which is in pound. Okay, 24,625 pound for cylinder number 1. Okay, you should take the average of 3 cylinders. Okay, the strength, which is in a unit of PSI or pound per square inch, is the total load in pound divided by the areas, the cross section of the cylinder. Okay. All right, and also don't forget to do the discussion, answer the questions. For example, why it is important to do capping before the test, and how does 1, 2, 3, and 4 week strength compare to each other? Okay, and how does the 28-day strength compare to the design strength, the specific strength, and also the required strength that we use for our concrete mix design? Okay. So next, let's look at the video. Okay.
Lastly, I prepared my concrete samples, and today, after 7 days, I'm gonna test it for the compressive strength. But before, I'm here to cap my samples. As I explained, the upper and lower part of my sample is not even enough. And if I don't cap my samples and both sides, what I'm get is concentration of the stresses, and the numbers that the compression machine is going to show me is not accurate, typically lower than reality. So what I'm going to do today is just, using this capping compound. So I made it 2 hours ago because I need time for this compound to totally melt the compound. Actually, the heater melt the compound. So it is like liquid, black liquid. It is super hard. Be careful. It is 450 degrees, and we need to wear something suitable to cover our skins. If for any reason splashes on our hands and arms, the covering could help us a lot. We just need a suitable mold. We have 3 different molds depending on the size of your sample. So the smallest one, the medium size, and the large one. For my case, I just used the medium size because it, proper for the size of my sample. And before pouring the compound in it, I have to use oil. So use oil, motor oil, but not too much. I just make sure that I cover all around the mold because it's going to splash on the mold, and I don't like to struggle with the mold just taking out my sample for several minutes. I just clean up the excessive oil because I like to have something totally even. If you have excessive oil on the mold, the capping surface is not going to be perfect. You might see some bubbles on the surface you're capping, and I don't like it. Okay, so my mold is ready. What I need to do is, after I pour the compound into my mold, I put my sample in its place and try to hold it vertically to this part, because this part helps me to keep it vertical. And then these 2 surfaces is going to be parallel. Otherwise, I'm going to get something like this. So make sure that hold it for some seconds, and after some seconds, the compound is going to cool down and turn into something solid, and then you can release it. So the surface of my sample is not that bad, so I don't pour that much of compound, just a little bit, to make sure that it cools down quickly. So be quick and be watchful about yourself. I'm holding it for some seconds. If you look at the capping compound, it is dark green now, and it is, glassy. And it is turning into something, with matte color. When it is not shiny, it means that your capping compound cooled down, and you can release your sample, but don't grab it yet. Wait a little more. And it is ready, so you can take it out of the mold. And you get something like this. Nice and flat. And do the same for the other side of the mold, other side of the sample. Exactly the same procedure. There you go. So I have both sides of the sample capped. These 2 are totally level, exactly what I wanted. And then I can go to a compression machine and test it for the compressive strength. So let's go to the compression machine. Okay, guys, my sample is ready. I cap it, and I'm gonna test it for the compressive strength right now. We have different types of compression machine. For this machine, it is not completely automatic, so it is, semi-automatic. So just, start with the setup. I make sure that the shape and the size of the sample is correct. Just press the cylindrical size and make sure that it is 4 inches. Another important part is the rate of applying the load. It is 500. It means 500 pounds per second. So the speed of the machine when it applies load, and then enter. In here, I have a lever that can control the speed of the machine. So I typically close the valve and put it on the control advance to make sure that I have enough control on the machine. I need to make sure that my sample is right in the center of the lower and the upper plate. Otherwise, we don't have the accurate number. So good to go. So you can see there is a gap here. So there is a gap here when I turn the machine on, and when it goes up, I do like the top part touches the sample, just get as close as possible, and then I'm gonna put it on control advance and open the valve. And make sure that right before applying load, we tear the machine and the machine shows zeros. And when it's done, that is something like this. The lines goes to the far left or far right and doesn't move, something like this, and I'm done. But just to show you guys, inside my concrete, I just continue applying load, crash it well. Here you go. And then turn the machine off. For normal concrete without silica fume or super plasticizer, something like this, the pace is not that strong. It means that I can take the aggregate easily out of my sample. It means that in this case, if I increase the strength of my aggregates, doesn't matter. I cannot increase the compressive strength of the concrete. If I want to increase the strength of the sample, I need to think about the pace first, because my glue was not that strong. I could, detach the aggregate particle easily. It means that stronger aggregate cannot help me. For high strength concrete, what we typically do is just strengthening the binder. When the binder is strong enough, then it's time to increasing the quality of the aggregate. I'm gonna take all your samples, put it on the machine. So for each part, for example, 7 days strength, I need 3 samples, put them under the machine, test them, write down the number, and then send you the data. You need to make the average from these 3 numbers for 7 days, and then next week for 14-day, 21-day, and 28-day compressive strength. These numbers are not compressive strength sample. They are the ultimate load that your sample could tolerate. You need to divide this number by the cross-section area of your sample, that is P d squared over 4. So you just need to divide this number, that is 26,835 divided by 12.56, and the result is going to be the compressive strength of this sample. Then you have 2 more numbers, make the average, and report for the 7-day compressive strength of the sample according to the data I'm going to send you. Thank you, guys.
Okay, so what Reza said is very clear. Remember the fracture surface. For this normal concrete, the fracture surfaces basically go around the ITZ. Okay, so the aggregate itself does not crack, does not damage. So let go back to the weakest link series we talked about earlier. For normal concrete, the weakest link is the cement paste and ITZ. So the aggregate is strong and is not touched. Okay, so and just follow what he said about how to calculate the compressive strength and do the curve. Okay. All right. Let me see. Yeah. So that's about for today's lab. Okay. So I already uploaded the result for 7, 14, 21, and 28 days. How much load in pound the cylinder can take. You can go back to calculate the compressive stress. Okay. So any questions before we dismiss today? Okay. Thank you so much. I will see you Wednesday. Thank you.
Wait, Professor?
Yes.
Did you